Hi guys, I hope you're good. I hope you're well and excited for our lesson today. We are still working with equations and we are looking at solving word problems once more, and we'll be using simultaneous equations this time around, and we'll also be looking at rates specifically. So yes, we have worked with some simultaneous equations before, and we've also worked with word equations before, but this time around we look at the rates firstly. Okay, so before we actually go into the actual examples that I have for you, I want us to look at the strategies that we use whenever we need to solve word equations. So the first part says read the whole question, guys. So we need to read the question so that we can understand what are we really trying to do. And the second part says what are we asked to solve for. So we need to look for that also. What is it that we're trying to solve here? The third part, assign a variable to the unknown quantity, for example x. So we use x most of the times as our unknown variable so that we can easily assign that. And number 4, translate the words into algebraic expressions by rewriting the given information in terms of the variable. So you need to make sure that you change the language, guys. So you translate the words into mathematical language, which is called algebraic expressions. So that whatever information that you have, you need to write it in terms of the given variable. And number 5, set up an equation or system of equations to solve for the variable. That's what you need to do, guys. Always you need to set up an equation or a system of them so that you can understand and try to solve for the variable. And also you need to solve the equation algebraically using the method called substitution. And lastly, you need to check your solution if it makes sense. Looking back at what you were given as the original question. So in front of you, you have a normal everyday question which looks into money. So money also falls under rates. Okay, so you have an example of fruit shakes and chocolate milkshakes. So you will be comparing prices of those products against one another, but then at the end of the day, we need to find the individual prices. So reading the question says, a fruit shake costs 2 rand more than a chocolate milkshake. So the first most important thing that we need to do is to assign variables, guys, to our problems. So as you can see, we have a fruit shake on one side and we have a chocolate milkshake on the other side. So we can easily use F for the fruit shake and we can easily use C for the chocolate milkshake. Okay, so at least we have our variables there. And if 3 fruit shakes and 5 chocolate milkshakes will cost 78 rands, find or determine the individual prices. So we need to first go create our first equation from the first statement. So it says a fruit shake, so it means F costs 2 rand more than the chocolate milkshake. So it means the chocolate milkshake plus 2 rands. That's the price of a fruit shake. Okay, and looking at the second part, if you have 3 fruit shakes, so if you have 3 fruit shakes and 5 chocolate shakes, so if 5C, the whole cost of that will be 78 rands. So that is your price. Okay, so now you have those two equations, guys, and we need to solve them. Okay, so the first part, it says F equals to C plus 2. So the first part, it will be F equals to C plus 2. And the second part says if you have 3 fruit shakes plus 5 chocolate shakes, you will pay 78 rands. So that is what you have. So now we can easily say you have equation number 1 and equation number 2. That's what you have there. So guys, now this becomes a clean substitution problem because equation number 1 already has the fruit shakes as the subject of the formula. So you can easily say substitute equation number 1 into equation number 2. So equation number 2 says 3f plus 5c equals to 78. So it means whenever I see f, I have to substitute in c plus 2. So in the space of f, that will be now c plus 2. So this will be 3. You open your bracket and then you have c plus 2. And you continue with the rest of the equation, which is 5c equals to 78. And now, if you substitute in the value, so it's 3 times c, you have 3c, and 3 times 2, that gives you 6. And you continue, you have 5c equals to 78. Now, grouping like terms, guys, you will find yourself with 3c plus 5c equals to 78 minus 6. So that is what you'll find yourself with, guys. And then lastly, you have 8c, because 3 plus 5 is 8. So you have 8c equals to what is 78 minus 6. 78 minus 6 will give you 72. So now if you find yourself with 72, so it's quite easy that you now simply divide both sides by 8. So if you divide both sides by 8, so you say divide by 8, so c divides c, you're going to get c. So what is 72 divided by 8? So 72 divided by 8, that will be a 9. Okay, so that is 9, because 9 times 8 gives you 72. So you have c being 9. So that is chocolate milkshakes, right? So you have 9 chocolate milkshakes, guys. And also now we need to substitute the value of c back into any of the two equations this time around that we have, and see if we're going to find the answer. So you find yourself with, you can say, substitute c equals to 9 into, let's see, an equation that has a subject is already equation number 1, so we can substitute it into equation number 1. So if you substitute in equation number 1, let me just write equation number 1. It says f equals to c plus 2. So c is given as 9, so f equals to 9 plus 2. So therefore f is given by 11, because 9 plus 2 is 11. So you have 11 fruit shakes and you have 9 chocolate milkshakes, guys. So this is how you solve that kind of a problem. That's an everyday life kind of a problem, and it has more practical things that we are used to in our everyday lives. Okay, so yes, that was one part of it, guys. However, I have another more advanced question that we need to familiarize ourselves with such type of questions, because this works also as an exam preparation, as a test preparation, so you may find things of a higher order like these ones. Okay, now in this problem we are working with something different. So 2 jets are flying towards each other from airports that are 1,200 kilometers apart. And so it means that is the distance between them, so it's 1,000 kilometers. And one jet is flying at 250 kilometers per hour. So for those who don't understand, 250 kilometers per hour is speed, okay? And speed is rate. So that is why this question is applicable here, because we are dealing with rates here. Speed is actually the change in displacement over time. So that is why we say it's also applicable in this scenario. It's actually changing distance over time. So that is why it's applicable here. It's a rate, okay? So yes, we have a rate there, which is 250 kilometers per hour. And the other jet at 350 kilometers per hour. So you have 2 different speeds there, guys, because you have 2 different jets. If they took off at the same time, how long will it take for the jets to pass each other? So guys, this problem needs you to focus, because you are now dealing with 2 situations, two independent events that are happening, but we need to find that time, or how long will the jets pass one another. So when will they cross that point in time, we need to record it. So how long will it take for that event to occur? So now this is where we break down every detail that we know. So for the details that we know, guys, is that we are dealing with two jets here. So we have jet 1 and jet 2. Okay, so now first let me just write all the details that I know about jet number 1. So jet number 1, in terms of if you want to talk about speed, we know its speed. So the speed of jet 1 is 250 kilometers per hour. So we're talking about 250 kilometers per hour. And for jet the distance, guys, this is where it comes. So these two jets, they're 1.5 kilometers, 1.2 kilometers away from one another. So this is how we do it. So we simply say this is going to be the distance will be 1200 minus x. The reason why I said minus x, guys, is because we don't know the position of the other aircraft. So for us to know how far they are from one another, or the distance between them, we need to ensure that we say 1.2 minus the value of x. Okay, so it means x now talks about the other aircraft, and t, which is the time, is what's unknown at this point, because we don't know the time, guys, it takes, right? So that is why t, it's still simply t there. And what we'll do now is now also write down things we know about jet number 2. So for jet number 2, what we know is the speed is 350 kilometers per hour. 350 kilometers per hour. The distance that the second aircraft is will simply be x, because that is the distance between them. So if you want to find the difference between those two, if you take 1.2 minus x that we have on top and we subtract it with x, it's simply just going to be 1.2. Okay, so that is how you find the difference of those two aircrafts. So now in terms of time, we can simply use t. So guys, now this is what we do. The formula for speed is given by distance divided by time. And now let me just use that concept for jet number 1, for example. So for jet number 1, let me just do jet number 1 in green, and then I'll do jet number 2 in orange. So the speed of jet number 1 is given as 250 kilometers per hour. And what is the distance? The distance is given as 1200 minus x divided by time t, because we don't know that time, right? And that makes us, we can easily actually make t the subject of the formula. So t is given by 1200 minus x over 250. So now we can say that is equation number 1. So for equation number 2, guys, let me use a different color. So for jet number 2, the formula still applies as speed equals to distance divided by time. So it's still the same rules still apply. And if I have things in such a case, so this means I have the speed given as 350. So I have 350. So I have 350 equals, what is the distance? Distance is x over time. So my time is t. So making t the subject of the formula, you have x over 350. So that is your equation number 2. So now the interesting part on this one, guys, is both of our equations have t as their subjects. So I have t here, I have t on the other side. So therefore I can make equation number 1 be equal to equation number 2. This is the third method of simultaneous equation, which is called equating, guys. So where you equate equations. If you see two equations with the same thing, you can simply now write it this way. Because t, both sides have t, so I can write now equation number 1 on the underside. Let me just write it on top there. So I can simply say this is 1200 minus x over 250 equals to, so now I equate it to the second part. So this is equal to x over 350. And what you do, guys, now you cross multiply, just like we did in one of our previous lessons, which is called cross multiplication. So we used a method called cross multiplication, guys. So this will be 350 multiplied by 1200 minus x, and with this will equate it to 250 50x. So I multiplied this value with that value, and I did it vice versa on the other side. So now if I want to simplify this, so I need to find the product of 350 and 1200. So if I multiply 350 and 1200, that will give me 420,000. And if I multiply 350 with negative x, so that becomes minus 350x, and I equate this to 250x. So now let me just add values. So it means I need to group like terms. So I need to take the 350 to the other side. So I'll be left with 420,000 equals to 250 plus 250x plus 350x. So I took the 350 to the other side, guys. That's why it's positive. So 420,000 is equals to 600x, and we are going to divide both sides by 600. So we divide both sides by 600, and so that 600 cancels the other. So therefore x is given by 700. So that 700 is actually in kilometers, guys. Remember that it was 700, the value of x there, so it's in kilometers. So that was the distance. Okay, so that was the distance that one of the aircrafts traveled. So once we have such a case, guys, we can now easily go back to the original equation of speed, that says speed is equals to distance divided by time. So if I'm looking for time, time is given by speed. Okay, so time will be given by distance over speed. And you already have what? You already have the value of your distance there, and you know speed, so you can choose any of the speeds that you have, guys. So you have the one that says 700 1.2 minus x, or you have the one that says x. So let's just choose the speed of jet number 2. Okay, so we just use 700 as our distance, so we can say this is 700. So we choose speed of jet number 2, so it was 350, so we divide this by 350. So we know 700 divided by 350, that gives me 2. And that time, guys, because we're dealing with kilometers per hour, so it means your time is in hours. So that's how long it took the two jets to meet, guys. So even if you can substitute these values, you can use the first one that says 1.2 minus x, so it's going to be 1.2 minus 700, and then you will divide it by the speed that you have. You will still get 2. So guys, this is how you work with this kind of a problem, and these are simultaneous equations working with the issues of rate. So you need to be very careful whenever you work with this type. Okay, so guys, thank you for joining me on this lesson today, and I will see you on the next one.